we're doing confidence intervals and hypothesis tests for proportions. Everything on test 3 is going to be proportions. So if we scroll down here, you'll see I have some extra worksheets. Maybe we'll do some problems from this today. And we have some more extra worksheets. And then someplace, there's a test 3 guide that I'm looking for. Let me pause. Okay, I've added it in. It exists someplace else, but I can find it. So I've added it in here at the end of the chapter 1 module, a solutions guide for all of test 3. Like, you can have this with you when you're taking test 3. It literally walks you through the 4 different kinds of problems we're going to have. Like every step, every calculator button, everything. So this is a really useful tool. So I would recommend looking through that. So on test 3, which is, I don't know, when's that coming up? Let's take a look. We've still got a couple of chapters to cover. But you're only going to have 4 different kinds of problems. 1 sample, 1 proportion interval, 2 proportion interval, 1 proportion test, 2 proportion test. On the calculator, that's buttons 5, 6, A, and B. That's it. We don't have to do any of these by hand. We're going to use the calculator for all of them. And test 3 will be not even until the 9th. Here's practice test 3. We're going to go over a few different practice tests. We're going to get a lot of practice. So you've been doing some confidence intervals. Here's this group assignment that's due soon. I've looked through your drafts on these, and they're not all great. First thing you got to decide is, what are you calling success and what's your population? Population is a group, not a number. It's the group you're trying to study. So here, a stats professor asks her students, there's your group you're trying to study, whether they are registered to vote. There's success. So from that, you can define your variable. This line right here, be sure to define any variables, means defining our main variable here, which is P. So the very first thing you should write down is let P be the proportion of, and then a bunch of words. Now you got a sample. So there's that's a population size right there. We don't use that for anything. The only reason that's there is so we can check the conditions. If you use the 700 for any calculations, you're making stuff up. In her sample, we've got an X and an N. You can find your P hat, type everything in the calculator. It spits out your confidence interval. The hardest part, honestly, is just interpreting the confidence interval. And it's always, we are 95 or whatever % confident that between blank and blank % of these did that. Of the population is successful. Don't mention the sample here. We're not making predictions about the sample. She did the sample. She's got her sample numbers in front of her. We know everything there is to know about the sample. We're making predictions about the entire population. So don't say anything in this space right here about we're confident this or that about the sample. No, we're confident about the population. Okay, let's talk about hypothesis testing. Hypothesis testing, like I've said this a couple times, it's a steep learning curve. It's tough the first time you see it. Let's take a look at the homework. Now, most of these homework problems have videos attached to them. One of them, yeah, it was this one. He does it all by hand. Like, maybe I should take that video out. You do not have to do it by hand. Like, we can use the calculator to do this. That's an alternate way to do it. When I first started teaching this class, that's the way I would teach. That's how we would do confidence intervals. We don't have to do that here. We've got these fancy calculators that are required for the course, so we're going to use that. All the other videos you can see are using the calculator. So let's go through one of these, start to finish, write it all up and all that. So here, I was going to make up a problem, but we'll do this one. And I'm going to write this up like this was a written assignment. I covered up the beginning of the problem. That's okay. There was nothing important there. Okay, so it was believed that 38% of homes were heated by natural gas. We did a sample, and the sample is going to contradict that. If the sample agreed with 38%, we're done. We're like, yeah, it's probably right. The whole idea is that the sample is going to say, oh, you were wrong about something. So either it was just a random fluke, samples vary, it happens. Or maybe that original number was wrong. Or maybe it was a bad sample. So the first thing we got to do, I keep saying words and people don't listen to me. You have to define your variable. Let P be the proportion of what? Homes heated by natural gas. Okay, we thought or we believed that P was 38%. That's what was reported before. So that would mean Q, which is always 1 minus P, would be 62%. Okay, that's going to be our P naught in a minute. Okay, then we have our sample. Our sample is always going to come with an X, an N, and a P hat. They're going to give us 2 out of the 3, and we have to find the third. My thing's in the way. 150 out of 339. X is the number of homes in the sample heated by natural gas. The actual number of successes in the sample, not a percentage. X is a whole number. N is the sample size. P hat is your sample success rate. All right, let me get that calculator out. So 150 out of 339. 44.2. We'll go 3 places here. That's more than what we originally believed. So we're going to write our hypotheses. Hypotheses are complete sentences, not numbers. You're never going to, I see this all the time. People will write equals 38. I believe that 38. What? No. The hypothesis is we used to believe that P equals 0.38. And again, that's the P naught number right there that the calculator is going to ask for in a minute. A complete sentence, P equals a number. Every one of these, P equals a number. And then for our alternative, we look at this number and say, is that bigger? Is that smaller? Are we just saying if it's not equal to? We're always going to have P here. We're always going to have the same number. Always. These will be the same. The question is, what do we write here? Greater than, less than, or not equal to? If they don't tell you to use not equal to, and not equal to is rare. Like the first homework problem here does it. On a test, I never use the not equal to on a test. So that's not your first go-to. Your first go-to, the first thing you want to think is either greater than or less than. And you look at the picture, or you look at the number to see, is that bigger or smaller than 38? That's bigger. So we used to think 38% of homes are heated by natural gas. The sample says it might be bigger than that. We draw a picture. We're supposed to check the conditions, but I know I meet the conditions. You know how I know that? Because they ask me to make decisions. If I don't meet the conditions, I can't even get this far. See, I'm on this one. See how they're asking me to find a p-value? You can't find a p-value if you don't even meet the conditions. But we're supposed to check the conditions. And the conditions are, did we take a good sample? Is our sample size large enough so that these two conditions right here, and are the samples independent? Look at the rest of these that they have here. That's a mean condition. That doesn't apply here. That one, that's for means. That doesn't apply. Both of these, there's no standard deviation. There's no mean. Those are means. All, like whoever wrote this up, all of those are for means. This is the only one that applies to proportions. So like, that's the only one. Oh, by the way, we're doing a test for a proportion. I know we're doing a test. By the way, how do I know this is a test and not a confidence interval? Because it says the word test. It gives me an alpha level. Confidence intervals will always say confidence interval, always. Hypothesis test doesn't. And they'll always give you an alpha level. Okay. So now, we know that all the p-hats, because we meet the conditions, I'm not going to bother writing down the conditions. The p-hats follow a normal distribution. Right here in the middle, the mean is p naught, which is 0.38. And my sample is up here, 0.442. We always shade a tail. We always shade one of these little tails here. So watch which way I'm shading here. I'm going to shade that way. I'm going to shade that direction. Like imagine this is an arrow. Look at that like an arrow. I'm shading that way. That's the same thing I wrote there. Those will always agree. This is why I require that you draw a picture, because the picture is the check to make sure you wrote this one right. Now the calculator does all the work. Remember, you're only going to use buttons 5, 6, A, and B for the next couple of weeks. So let's look at 5. That's the right one. Let's look at 6. They're asking me for X1, N1, X. I don't have all that. No place on my page did I write down an X2. I don't have two X's. That can't be right. Let's look at A. They're asking for a confidence level. I don't have a confidence level. I'm not doing oh, that says interval right there. Look. I'm not doing an interval. I'm doing a hypothesis test. That can't be right. Let's look at 5. Oh, wait, this is all the stuff I just wrote down because this one's right. So the P naught, that number we believed before we did the sample, we believed that 38% of people heated their house by natural gas. Then we got our X and our N. I'm going to do this wrong. I'm going to get the wrong hypothesis, alternative hypothesis, because I want you to see this. Now you can go here to calculate or draw, and it'll draw this picture for you. But I don't really like the way it draws it. Because it kind of makes it look like zeros in the middle, and it's not. And 38's in the middle there. But still, like we can draw the picture, and that's the wrong picture. And there's my p-value. I'm going to do it the other way. I'm going to go calculate instead, so the picture is not in the way. Here's my p-value. If you get a p-value bigger than 0.5, bigger than a half, you done goofed. This is wrong. This is 100% wrong. You will never get a p-value bigger than 50%. That means you chose the wrong alternative in the calculator, or you just completely goofed. Look at that. That's 99%. P-values we expect to be small. Remember, the smaller the p-value, the stronger the evidence. Small p-value is strong evidence. It's counterintuitive. This p-value is not the probability of something being true or false. That's not what it means. The p-value is the probability of getting the sample that you got if the null hypothesis is true. So small p-values mean unlikely samples, which means either you had a bad sample or the null hypothesis is not true. So I know I said this in one of the other videos. Think of it like you're on a jury for a criminal trial, and they've done a DNA test, right? And they say, we did this DNA test, and there's a 1 in a billion chance that this DNA belongs to somebody else, and it's not Bob, the killer. That's really strong evidence that Bob did it. There's only a 1 in a billion chance that it was someone else. That's what the p-value is like. It's the probability that someone else did it. And if that's small enough, that means Bob did it. Okay, so when we go back in here, this is the correct one. Look what I wrote right there, greater than. See how I wrote greater than? See how I shaded above? I want greater than. I wish the calculator wrote this out better. What they're asking us is this part right here. They're saying your alternative hypothesis is P is what? Greater than P naught. I hit calculate, or here, let's hit draw again just so we can see. Look, that looks like what we drew. But I prefer calculate. All right, there's my p-value. There's my z-score. You're going to have questions that ask for the test statistic, 2.37. And then the p-value, the one I actually care about, was 0.008. The reason a lot of places or a lot of homework questions might ask for the test statistic is there's a different way to do hypothesis testing. Because back in the day, we didn't have these fancy calculators, right? Calculating the p-value by hand, it's a lot of work. Finding the z-score is pretty easy. I mean, it's still some algebra and some arithmetic, but you can do the z-score with just a scientific calculator. So back in the day, rather than going through the trouble of finding the p-value, we stopped here because this certain z-score has to be so many standard deviations away from the mean. Like that's what the z-score means. So we used to do this thing called rejection regions. If your z-score is bigger than 2, you reject. If it's smaller than 2, you fail to reject. It's just an alternate approach. So you'll see some of the homework questions, like even this one, asks for the test statistic. On like the written assignments, I don't ask for that because this is what we really care about. And we got these fancy calculators. Okay, now that we got the p-value, we compare it with alpha. Less than alpha, if the p-value is less than alpha, reject the null and accept the alternative. If it's greater than alpha, you fail to reject the null. You never, ever, ever, under any circumstances, accept the null. That's a comma right there. This says HO, comma. Reject the null, accept the alternative when your p-value is really small. Small p-value is strong evidence against the null. So now we would write that out. I'm going to type it. We have strong evidence that the proportion of homes heated by natural gas is, in fact, more than 38%. See, I just said I accepted this. I rejected that. We used to think it was 38%. That sample said, that's pretty unlikely. So this one's out. That gives us strong evidence to back up this one. So that's our last step. We're always going to write every single time. We either say we do have strong evidence and we're going to write these words, or we don't have strong evidence and we're going to write these words. We're going to write what this means in words every time. And like, look at this. This says, what's P stand for? The proportion of homes heated by natural gas, greater than 38%. In this case, because of this, because we accepted the HA, we do have strong evidence that that's true. All right, so now how do we fill in all of this? So we got all these choices here. On test 4, when we're doing means, it's going to be that guy. For every single problem, mu's. We don't have any mu's here. We only have p's. And this one's always going to be equal. And that was 0.38. And these two numbers are always going to be the same. You never use two different numbers. Here, this was p is greater than 38. Okay, this was the original claim. Right there. That's what the original claim was. This was 2.37. My p-value, I think, was 0.008. I'm doing all these from memory. I'll have to fix these if these are wrong. We rejected the null. Never, ever accept the null. That's not even allowed. The only two choices are fail to reject the null and reject the null. Our level of significance was 5, and we said there is sufficient evidence to support the claim that more than 38%. That was just wrong. What was our p-value? Oh, I guess I better round that up to 9. That's not true. I'm gonna have to go in and edit this question. The original, they only made one claim. So what's it? Yeah, something's wrong with the code on this one. I mean, look, it even says right there, there's the claim. I don't know why it's not giving me credit on that one. I just want to click that and see what happens. Yeah, I got it. Somebody goofed when they wrote this problem. That's not true. It was the null. All right, so I'll fix that. Okay, and then you'll see a lot of these questions are essentially the same thing. These take practice. So take your time on these. Don't just guess at them. Take your time, practice. Once this clicks, it's super easy. But it takes a little bit of practice for it to click. All right, I'm going to stop there. I'm going to go fix that problem. And I will have your midterms graded as soon as I can.